The frequency of a wave is the number of full wavelengths passing a point in a second. Remember that a wave is a way of transferring energy from one place to another without matter being transferred. For example, in a transverse wave, the matter would move up and down and form a pattern like this. We'd see the pattern move along as the matter changes position. Notice that this pattern repeats constantly. We define a wavelength to be the distance across which we have exactly one cycle of this pattern. For example, this distance here, between these two peaks of the wave. If we mark a line through one of these peaks, then we'll see that a full wavelength will pass this point when the next peak passes through it. So to measure the frequency, we watch the wave move for 1 second and count the number of peaks and hence full wavelengths which pass this line. So we count 1, 2 peaks during 1 second of motion. Since we'll see 2 peaks pass a point each second, there will be 2 wavelengths passing the point each second. So we can say this wave has a frequency of 2 hertz, where hertz is the standard unit for frequency. It basically means things per second. But is this the only way we can define and measure frequency? Well, frequency will also be the number of times the motion of the matter in the wave repeats in a second. Let's look at the motion of the wave again, but this time focus on a single particle that's oscillating in the wave. As the pattern moves to the right, we see that this particle is moving up and down to keep with the line drawn by this pattern. So its motion involves going back and forth across this distance. Now let's remove the wave and just focus on the particle. We'll see how frequently it moves up and down in this pattern. This time we'll measure for a few seconds rather than just one. This is a good habit to get into when measuring frequency, as it can be quite difficult to count and time accurately if you're only observing the wave for 1 second. So instead, we'll watch the motion for 5 seconds and see the particle return to this starting point once, twice. So it went up and down twice in this time. Since the particle went through 2 cycles in 5 seconds, we can calculate the number of cycles the particle did in 1 second by dividing 2 by 5. This gives a frequency of 0.4 hertz. Again, this is more reason for us to have watched this motion for more than a second. How could we have counted 0.4 of a cycle? So that's what the frequency of a wave is. But what determines what a wave's frequency will be? Frequency is determined by how quickly the waves are being produced. So let's understand this with another simple example. Here we see someone creating a wave in a spring by flicking it up and down at one end. When the hand is flicked up, it creates a peak in the wave, and when it's flicked down, it creates a trough. This then repeats to create the pattern shown. Each time the hand repeats its motion, the wave repeats its motion. So the rate at which the hand moves is the rate at which the waves are produced and the rate of their cycle. In other words, if the person moves their hand up and down 3 times in a second, then a point in the spring will move up and down 3 times in a second. So this is a 3 hertz wave. For your exam, make sure you're very comfortable with the definition of frequency and how to measure it. We'll be learning a lot about how the frequency of a wave affects its properties.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!